On the second part of 5.5, we're going to look at something called ionization energy. Remember, atoms are neutral, but when I add electrons to them or take them away, they're no longer neutral. You're creating something called an ion, which means it's not neutral. It either has too many electrons or not enough electrons. So what we're going to do in this lesson, we're going to define this thing called ionization energy. And then we're going to explain the effects of this ionization energy as we move across the periodic table on any given period, any given row, as we move across the row, or down a group as I go from one row to the next in the same group. And then from that, we'll explain the difference between the first and second ionization energies. Ionization energy is the energy required to remove an electron from an atom. In general, the energy that is required to do this, the amount of energy increases as I move across a period, across a row, and the amount of energy required to do this decreases, goes down as I move down a group on the periodic table. And there's a little table that shows. So I go across, it takes more energy. As I go down, it takes less energy. This is an actual plot. In fact, I did a few of these back in the old day. As we had lithium, for example, we were pulling off electrons. There's hydrogen, there's helium, to pull off the first electron. It's called the first ionization energy. So if we look at hydrogen, how much energy it takes to pull off its first electron versus helium takes a lot more energy. Lithium, to pull off its first electron, is pretty easy. If I pull off its second, I pull off its third, it gets harder. So as I go up to neon, which has all 8, that's the farthest one over on the second row, the second ring, takes a lot of energy. Not as much as helium because it's a little bit farther out, and so on. And then this is just basically a table of those values if you actually did kilojoules per mole of energy to pull it off. Each successive ionization energy requires more energy. So when you pull the first electron off of lithium, it doesn't take much energy. When I pull the second electron, it takes more. So again, ionization energy is the energy required to remove an electron from an atom. And this energy that is required increases as you move across the periodic table on any given row or period. So I'm going to start on the first row because it's just the easiest to do. So as I move across, it's going to take more energy. So the energy required to pull one electron off the hydrogen is going to be less than the energy it takes to pull the first electron off a helium atom. Why is that? If you look at hydrogen, it has one proton, that makes it hydrogen, and has one electron. And that electron will orbit in a cloud at a given distance, which has my little arrow here. So that's where this little guy keeps buzzing around in a sphere. That's his little orbital path. And that's hydrogen. Helium, on the other hand, has 2 protons in the middle. That makes it helium. So it has 2 electrons. But because I have these 2 monster protons pulling on the electrons, helium's 2 little electrons are actually pulled closer in. They're actually orbiting those 2 protons closer because they're so big, kind of like Jupiter's pulling in on a moon, than compared to just hydrogen with this 1 proton pulling in 1 electron. So each successive ionization or electron removal requires more energy. So therefore for helium, if you take its, we have helium here now, if you take its first electron and rip it off, that takes more energy than taking hydrogen's lone electron because it was a lot closer. Hydrogen's out here, so it's farther away. It's weaker pull of the 1 proton. Helium with the 2 big protons is closer. It takes more energy to pull that off than does even hydrogen's. And there's still less energy than taking helium's second electron. So the energy to take this first one off of helium is less than taking hydrogen. It takes less. Helium being closer takes a little bit more energy, but the energy to do that one is less than taking the second one off, the second ionization, because I have 2 protons pulling on the electron. So ionization energy, energy to remove an electron, again, from an atom, energy required to do this goes down or decreases as we move down a group in the periodic table. So if I go down, I'm adding rings of electrons. It takes less energy. Again, good old hydrogen, where I started with, has this one electron orbiting at a certain distance. Well, lithium has 3 protons, therefore it has 3 electrons, 2 on the first ring, and its third or valence electron on the second ring. So each successive ionization energy requires less energy because each new ring that I add, as I go down, I'm adding another ring to put that valence electron on. Each new ring's electron is a square of the distance of the ring inside of that. So if you took the distance here and you squared it, that would be where this ring is. So it's way out there. The next ring is a square of that. So in quick essence, the lowest ionization energy required to move an electron, is which? The first ionization energy, the second, the third, or the fourth? If you said the first, you'd be right. The energy required to remove the first electron, is another way you can say this, is the least amount because it's farthest out. Each successive electron gets pulled in closer because the protons are still there and they're pulling them in closer and closer. And that's the end of this section.